All right, so I'm going to be giving you guys two files today that are really, really helpful as we start to review for the free response. So we are going to begin moving into our review stage. We've learned every single topic in calculus that is going to be tested. There's one tiny, tiny, tiny thing that I'm going to have you memorize a little bit later. That's just, basically only ever a multiple choice question. We can just memorize it. But otherwise, we've learned every single new topic in calculus. So we're going to start really honing in and focusing on our review. And before we start that review, I want us to take a diagnostic test. So that's going to be your homework this weekend, is going to be to do a diagnostic test. It is going to be on a new website called Edulastic, which is kind of nice. It'll just do multiple choice questions for you on that section. It'll time you. So it'll be 30 minutes timed. And then it'll help me to just kind of collect the data nicely. It's a diagnostic test. That means you're testing where you're at. I am not going to grade this. You turn it in, you get full credit. If you cheat on it, it's the lamest thing in the world. Okay, a diagnostic test is literally to tell you what you need to study. If you cheat, you don't know what you need to study because you just cheated. So please, 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 there's no calculator on the multiple choice section. Don't use a calculator. Don't use your notes. And I would even recommend don't guess, okay? If you can make an educated guess, then guess. But if you don't know an answer, I would just leave it blank because that's going to give a better diagnostic than if you guessed a right answer. Okay, so for the multiple choice, I would say don't guess just for this diagnostic test. On the real AP test, please, please, please guess. But for this diagnostic test, don't guess. Then for the free response section, it is calculator. So you can use a calculator. So that's our homework this weekend. Now, I do quickly also want to go over these trends. These two are probably kind of the most helpful documents I can give you in terms of understanding the free response section and understanding what's going to be on it. So I know we can read, so I'm going to go through this quickly. These are just some general things of what you better know, what you definitely need to know. Whenever you see is, setting it equal to each other. You see the word at, it means you're plugging that guy in. It's usually an x value. Increasing or decreasing means to take the derivative of whatever you want to be increasing or decreasing. So if it says, the amount of rocks in a garden is increasing, you're going to take the derivative for the formula of the amount of rocks, right? If it says the velocity is increasing, you're going to take the derivative of the velocity, v prime, which will become a. So, whatever you want to be increasing, that's what you take the derivative of. Derivative positive would be increasing. Derivative negative would be decreasing. How much or amount usually means to take the integral. Units, when we take the derivative, we add on a per time. When we take the integral, we chop off a per time. IVT, you use IVT if you're looking for the same thing, has a value in between. So if you have f of x and you want to know, if f of x ever equals 0, and you have a negative f of x and a positive f of x, and they ask if f of x has a 0 and you have f of x, then use IVT, right? Whereas MVT is if you have f of x, but you want to know if the derivative is ever 0, then you're using MVT. You need to know tangent lines, the whole x1, y1, and m stuff. Yeah. For limits on the free response, you really don't get a whole lot of limits. Every once in a while, they might have the limit approaching infinity thing. So, the top bigger goes to infinity, or negative infinity. The top and the bottom are equal, goes to that a over b, and the bottom is bigger, going to 0. Do watch out for, if you have e to the negative infinity power, that flips down to the bottom. And then you might get L'Hopital's. We'll talk a little bit more about L'Hopital's. But remember to write the limit each time, and we're going to take the derivative of the top and the bottom. So you do L'Hopital's if you get 0 over 0, even infinity over infinity. And we'll talk about how to write L'Hopital's on the free response. Okay, for derivatives, anytime you have derivatives on the free response, if you see increasing or decreasing, you're going to take the derivative. So those are key words. You see increasing, you see decreasing, you take the derivative. If it says at a point, you're going to take the derivative, plug it in. If it says in an interval, you'll probably take the derivative, set it equal to 0, and do a number line. If it asks you to approximate a derivative or approximate a slope, if you have a graph, you're just using the slope. If you have a table or 2 points, you're doing y2 minus y1 over x2 minus x1. This is very, very common on the table questions. Okay, for integrals, integrals can never ever be at one point. You always need from A to B. So just be careful about that. Okay, rate in, rate out question. We're going to talk about this in a bit, but this is a common question, this rate in, rate out question. If you see amount, you're taking the integral. If it says how much entered or how much left, then you just take the integral. Okay, so if it just says, like maybe there's a pool and we're filling up the pool and it just says how much water went into the pool, you're just going to take the integral. You don't care about the starting value. But if it asks you for a total amount at a specific time, like how much water is now in the pool, that's when you add your starting amount plus the integral of the rate in minus the integral of the rate out. Sometimes this question will also have an absolute max or minimum question. In this case, you have to set the rate in minus the rate out, that's the derivative, to 0. And then you'll make your XY table. Okay, we'll go over those two as well. And then part C or D, a lot of times is a totally new equation on these. Okay, position, velocity, acceleration. This is a big, big topic. We did this last semester. So remember that kind of table, right? Like, position, velocity, acceleration. Going down the table, you take the derivative. Going up the table, you take the integral. So a lot of these depends on what you have. If you have the position and they ask for position, you just plug it in. If they ask you for the average position, you would do the average value formula. If you have position and they ask you for velocity, you're going to take the derivative and then plug it in. If they ask you for average velocity, and you're starting with a position graph like x of t equals, then you're going to do the average velocity formula, s of b, position at b, minus s of a, position at a, over b minus a. If they ask you for acceleration, you'll take the second derivative, plug it in. Okay. Sometimes instead of giving you position, like a x of t equation, they give you velocity. So if you're starting off with velocity, you have velocity. If they ask you for the position, this is where you do the integral, right? To get from velocity up to position, you do the integral. So you do s of b equals s of a plus the integral from a to b of v of t dt. If they don't give you endpoints, you would do plus c. If they ask you for the distance, remember anytime you see distance, that's the integral from a to b of the absolute value of v of t dt. If you have velocity, they ask you for velocity, obviously you just plug it in. And if they ask you for speed, you're going to if you have velocity, you just take the absolute value. And then if they ask you for acceleration, you're going to take the derivative and plug it in. One thing I should add to this is if they ask you for the average acceleration, you would do this formula, but with, v of b minus v of a over b minus a. I'll add this right now. Okay, so kind of what I added is if they ask you for acceleration, you start off with velocity. Normally, you're just going to take the derivative and plug it in. But if they ask you for the average acceleration, right, you're going to do v of b minus v of a over b minus a. If they ask you for the average velocity and you have velocity, you'll do 1 over b minus a. A lot of times students get confused on this because, the word average, we could have two formulas, the average value or the average rate of change. What you want to remember is you do average value, the integral formula. If you want the average of the same thing you're starting with, then you do the integral. If you want the average of its derivative, right, you're starting with velocity, you want the average of acceleration, which is its derivative, that's when you do the whole like y2 minus y1 over x2 minus x1 thing. Okay. Lastly, they could give you a formula for acceleration. If they ask you for the position, and you're starting off with an acceleration formula, you have to take the integral twice, and you add c each time, and you solve for it. If they ask you for the velocity, and they just give you one endpoint, then you take the integral once and add c. Or you do v of b. If they give you two endpoints, then you do v of b equals v of a plus integral from a to b. We're going to go over a lot of this stuff, so if it's overwhelming right now, just kind of bear with me. And then if you have acceleration, they want acceleration, you plug it in, or you do the average formula. Okay. Another question that's pretty new that pops up a lot is this moving towards or away concept. So you need to consider both the position and velocity. Okay, you're going to consider both position and velocity. If the position, you kind of make a little chart. If the position is positive and the velocity is positive, we'll be moving away. So if those signs are the same, you're moving away from the axis. If the signs are opposite, you're moving towards the axis. Again, we're going to go over this. Speeding up, slowing down is very similar. Speeding up is when the velocity and the acceleration have the same signs. Slowing down is when they have opposite signs. Like I said, if you see any of these increasing, you take the derivative of that anything. Another really common question is this g of x equals the integral of f of t question. Usually they give you the graph of f. So we just did this in chapter 7 and the chapter before this one, where, basically the g of whatever it is, you're going to do the integral, the area under the curve. For g prime, you're going to change this to g prime of x equals f of x. So those are our y values. And for g double prime, we would set it to f prime of x, and that would be the slope of the graph. So this would deal with concave up, concave down. This would deal with increasing, decreasing. Another one is a table question is very common. A big thing they're almost always going to ask you if you see a table is for the approximate rate of whatever's in the table. So, taking the estimating the derivative. So you do y2 minus y1 over x2 minus x1. Almost every table question, this is part A. Usually part B is a Riemann sum. So we need to make sure we review our Riemann sums, like our left Riemann sums or right Riemann sums. The integral itself will be the Riemann sum. Sometimes they might ask us to approximate f of 6. And, then you might have to, do some kind of a FTC thing where you do f of 6 equals f of 0 plus the integral from 0 to 6, where this integral from 0 to 6 part you do with a Riemann sum, but then you have to add your answer with the starting value. That's a little more complicated. And then for units, if it says average value, the units stay the same. But if it's just a regular integral, you chop off the units. And then there's the area volume stuff, which we just did. Area is top minus bottom. Volume, pi integral of big R squared minus little r squared. Cross section, volume is the integral of the area of that formula. And then we have the slope fields. We have those particular solutions, right, which is where we separate x and y with dx and dy. We integrate, we plug it in. We have implicit. On implicit, if you see a horizontal tangent, you set the top to 0. If you see a vertical tangent, you set the bottom to 0. That's of the slope. Okay. And then for approximations, anytime you see the word approximation, if it asks you to approximate f of c, use a tangent line. That's like the y value. Sometimes they ask you, is it an over or under approximation? If it's concave up, it's under. If it's concave down, it's over. For f prime of c, they might ask that, the derivative. You do f of b minus f of a over b minus a, right? y2 minus y1 over x2 minus x1. And then if they ask you to approximate integrals, we do Riemann sums. We do a right Riemann sum, a left Riemann sum, or a trapezoidal, and make sure you know, for right, increasing is an over approximation, decreasing is an under approximation. For left, increasing is under, and decreasing is over. And for trapezoid, I didn't put this in here, but I'll add it right now. For trapezoidal, concave up is over, concave down is under. You can do this by kind of graphing it and just drawing a trapezoid underneath it. But if you forget, here's my shortcut. It's always the same as the tangent line ones. So if you remember the tangent line ones, trapezoids are the same. Okay. So we'll go through a lot of these concepts, but I just wanted to give you a heads up on this file. Read through it, remember about it. This is a good thing if you have a printer to print out and kind of as you're doing some of these questions, just have out as like big tips and reminders and key phrases. Okay. The next thing we're going to look at is just what do these problems look like? And so I have kind of different themes. Okay, what I've done is I've gone back between the last 11 or so AP exams from 2009 all the way to 2019. I didn't do last year's because last year the AP test didn't look like it normally does. But from 2009 to 2019, I've kind of gone and I've sorted everything, okay, to give us kind of what are the big topics and what are the trends, what can we expect on our AP test. So I kind of sorted the frequency. We'll notice the most common are this table of values question with the Riemann sum. This happens 11 out of 11 years. And the analyzing the graph of a derivative question happened 11 out of 11 years. Okay. Literally 2009, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Every year this question happened. Whereas some of the less common ones are like continuity, related rates, curve sketching, tables. And then this other seems low, but I want you to look at the years. 16, 17, 18, and 19. So literally the last 4 years, they've added this other question every time. I would really, really expect that this other question will show up. Okay. Another trend that's kind of weird is one of the really common ones is area and volume. But if you notice in the last 4 years, it only happened once in 2019. So it's happening every single year. And then all of a sudden they didn't do it in 16, 17, and 18. So who knows about this question? It used to be like a guarantee, and now it's, maybe. Okay, if we look at the last few years, like 14, 15, 16, 17, 18, 19, the rate in, rate out questions happening every year. Okay, 16, 17, 18, 19, the velocity, motion questions happening every year. and this table question, analyze and graph question, I would guarantee pretty much those four, 1, 2, 3, and 4. Those four I would almost guarantee are on there. I would guess a slope fields question would be on there, but it's not always. And then I would guess another question would be on there. But potentially we could have, the area and volume. Potentially we could have the related rates question. The related rates question did happen last year. And sometimes, some of these questions are kind of doubled up, and I'll show that as well. So I want to just quickly show, within the details, this is saying what each question is going to ask you to do. So kind of going through these, the particle question. You might need to convert between position, velocity, and acceleration, speed and distance, averages of these, and then, speeding up, slowing down, things like that. So those are kind of what those are all about. And so kind of looking at some of these, this would be a really typical question, right? For time greater than 0, particle moves on the axis. They give you the formula V of t. Is it speeding up or slowing down? Find when it changes directions. This is kind of what those questions look like. Okay. Here's another one. Give us V of t. It's really common for them to give us V of t. They give us the position at some time. Find the acceleration at 3. Find the position at 3. This is going to be a derivative. That's going to be an integral. Evaluate the integral from 0 to 3.5 of V of t and the integral from 0 to 3.5 of the absolute value of V of t. This is the change in position. This is the total distance, and interpret the meaning. Then they give us a second particle, this time though with x, with position. And they ask us when they have the same velocity. So that's kind of hard. But, you take the derivative to get this over to velocity and then set the velocities equal to each other. So that's a typical velocity question. Next, we have these rate in, rate out questions. Okay, this is where we had the formula where the amount at some time A was equal to the starting amount plus the integral of the rate in minus the integral of the rate out. That's kind of the whole basis of these questions. So this has been a really common question that they ask a lot. And so kind of something like this: fish enter a lake at a rate modeled by E of t equals 20 plus 15 sine. And then they leave by this L of t equation. And so then they might ask, like, how many fish just enter the lake? If they're only entering the lake, all I care about is the integral of this. I don't care about the starting point. I don't care how many fish were in at the beginning. I don't care about how many are leaving. I just care about that integral. Whereas if they said how many fish total are there at a time, then I would do the starting plus the integral of the in minus the integral of the out. Okay? So that's kind of what these questions are all about. Sometimes these questions are kind of repeated with a table as well. Here's another one: people enter, right? So this is a rate in, rate out question. And sometimes they'll give you a table as well. I think I had one right here where, yeah. So this one gives a table for the out, and it gives an equation for the in. So this one's kind of combining the table question with the rate in, rate out question. Kind of interesting. The next one is our area and volume. We literally just did this this whole chapter, so it should be very, very familiar to us. So there was one on this last test about this one, right? So very familiar to us. Find the area of R. Region R is the base of a solid. Each cross section is a whatever shape, and then what's the volume when we rotate this about some line. Very, very standard questions. If you get one of these, be thankful, because they're very easy to get a lot of points on. Okay, next we have the table questions. So question 2 here was a table question. And sometimes these are combined with velocity. So this one is combined with the velocity of a particle. So we have the velocity of some particle, and they give us a table to go along with it. And so a lot of times, question A will be y2 minus y1 over x2 minus x1. In this case, they said justify why there must be. When we see that, we're probably thinking IVT or MVT or rolls. Question B is almost always a sum, trapezoidal sum, or a Riemann sum. In question C, usually what they do on question C on these is they give us a brand new equation and they ask us to kind of relate them. So we'll practice these, but this is very common. Is A and B go directly to the table, and then on C, they give you something new and they ask you to kind of relate the two. And so we'll go over those, but this is kind of the table question. Okay, next up we have analyzing the graph of a derivative. This is super, super common. Like I said, these two have been on every single AP exam. So analyzing the graph of a derivative looks like this guy, or I believe there was one more right here. This guy. All right, so this is really common where they give us g of x equals the integral from -3 to x of f of t dt. So they give you the graph of the derivative and they say, hey, g of x is our integral. And they'll ask different things like find g of 3, find where this is increasing, find where it's decreasing. Sometimes on these, they do something else, like this one has a quotient rule. I've seen L'Hopital's rules asked here. I've seen tangent lines asked here. Find where we have a maximum, find where the graph is concave down and decreasing, find points of inflection, all that kind of good stuff. Right. Next up, we have the differential equations. Again, this was something that we just did pretty recently. So, 6. So they give us a differential equation. A lot of times they'll have a slope field. Either they'll ask you to draw the slope field, or they'll give you the slope field, and they'll ask you to just kind of sketch through something. And then the next one, this one, even though we see the particular solution, read through it carefully. It says write an equation for a tangent line, and then use your equation to approximate. So this is a tangent line question. And then this is the particular solution where you separate the dy and the dx, take the integrals and solve, plug in the initial. Usually this one is worth 6 points out of 9. This is always, I've said this before, but this is the single most amount of points for any question on your whole AP exam will be if they ask you to find a particular solution. And then everything from there is a lot smaller. So continuity, there aren't a whole lot of questions on it. They haven't asked it since 2012. It doesn't mean they won't ask it. Of course, as soon as I say that, that's going to be the year that they ask it, right? But here's a continuity question where, they give us an equation and they say, maybe find a derivative, write a tangent line. And then they gave us this piecewise and they say, is g continuous at 3? That's where we do those 3 rules of continuity. Like rule 1, f of x exists. Rule 2, the limit exists. And rule 3, they're equal to each other. So it used to be a lot more common, but with the rise of calculators, they haven't really asked it as much. Related rates, they asked kind of every once in a while, but they did ask in 2019. My guess is it won't be on our test. It's not so common, but it definitely could be. So if we take a look at the one from 2019, it was honestly not too bad of a related rate. They just gave a cylinder, and then they gave an equation as well, and the whole v equals pi r squared h. And so they did this one ended up being A and B were a related rate, but C was actually a particular solution question where you got to multiply the dh to one side, put the h on one side, put the dt on one side, and do separation of variables. So if you see that word separation of variables, that's that the y is on one side, the x is on one side, take the integrals. So this is kind of both a related rate and basically a dy dt question, a slope field type question. This curve sketching thing, I gave it its own category. It's something that, again, used to be asked a little bit and not so much common anymore. But just in case you get something like this, I want us to realize, they could give you some kind of a table like this where they give you, values for the original and for a derivative. They did it for f of x and for g of x here. And a lot of times on these, you just kind of want to sketch out what the shapes would look like. So we'll go over this question in particular, but it's not too common. And then implicit used to be super, super common on the free response. Now it's really more common on the multiple choice. So it's only been asked once in the last 11 years on the free response. And so it was question 6. Yeah. So here it is, this one. So they gave us y cubed minus xy equals 2. And they also gave us the derivative. So part A was write an equation for the tangent line, x1, y1, and m. Part B was find all points where the tangent line is vertical. You would take the denominator of the slope, set that equal to 0. And then part C was find the second derivative, which is where we do quotient rule here with implicit, and we'd have to plug it into itself. So that was kind of a trickier one. Okay, so if we do see implicit, we have to be ready for it. We don't want to just ignore it since it only happened once in the last 11 years. It's still going to be all over the multiple choice. And then the last one, this is question 6 on question 16, 17, and 19, and question 5 on 18. And so I just want to show us some of the weird stuff that they've been doing just so we can kind of take a look at it and just see some different looking questions. This one, they gave us a table. We'll kind of notice this is like chain rule, quotient rule, and then this is FTC. Honestly, this was not a hard question, but a lot of my students freaked out because they're like, wait, this wasn't like any of the main ones that we've been practicing. Again, the next year they did another kind of weird different one where they gave very similar, but now they gave a table, and then they gave a graph, and then they actually gave an equation. So they gave all 3 of these different things that we could have. And then they did find the slope of a tangent line. Easy question, right? If all they gave you was f of x and find the slope of the tangent line, you'd be like, oh, so easy. But a lot of my students freaked out because they had all this information and they just didn't answer, even though A is just x1, y1, and n. Okay, B is h of f of x. It's just a chain rule, h of f prime of x. Okay, but again, they're just giving you it in 3 different ways. C is a product rule, g of x times h of x. And within that product rule, you have to do a chain. And then D is there a number? When we see that is there a number, we're thinking IVT or MVT. Since we see G prime, we might be doing MVT, but we also have G prime, so we could do IVT there as well. Here we had question 5 was the weird one. So again, they gave us a function. They asked for average rate of change, slope of the tangent line, absolute minimum. It's really not that hard. It's just that it doesn't really fit into any of those other categories. And then here, question 6, again, was kind of that same concept where in this case, they gave us g of 2 equals h of 2 equals 4. And they gave us some line y equals 4 plus 2/3 x. They asked us for a derivative. And then they ask us for this, if we have a of x equals 3x cubed h of x, write an expression for a prime. And a prime of 2 based on this. So remember, h prime of 2, they gave us, or we found it in part A. And so you're just kind of using that as you go through it. This is a L'Hopital's rule question. And then this is actually a continuous question. So I guess I could add this to the continuous section. But anyways, I would expect something kind of weird. So we'll go over these kind of new weird questions as well as one topic. But, I kind of wanted us to just kind of see what these overall look like, okay? So I know this was a long video. We didn't actually really learn anything in this video, but I think hopefully this gives us more of an idea of, A, reviewing some of these words that we haven't heard in a while, and B, looking at what do the different types of AP questions look like. Because I've heard so many of you guys say, I start to understand it, and then I get to the free response questions, and they're just really weird, or I don't understand the wording. And that's really, really common. Like, you don't understand the wording. They're hard. For a high school student to understand them, who's taking their first year of calculus ever, it's hard to understand them. But the big, big, big thing is going to be repetition. Just like anything, if you play a sport, if you play a musical instrument, if you are an artist, the more repetition you get, the better you get at it, right? For my baseball players, if we go to the batting cages and they take just hitting and hitting and hitting and hitting, they're going to perform better when they get to the game, right? If you're a musician, the more you practice, the more muscle memory you create, the better you're going to perform. So same thing here is the more of these questions we can see and we can practice, what happens is, right now, if I give you a practice AP test, you'd go into the free response and it would just be like a jumble of everything. The goal is you open up a practice test and you immediately are saying, oh, you know what? That's a particle question. Or, oh, that's a, analyze tables question. Or, oh, that's an area and volume question. And you kind of even expect what A, B, C, and D are going to be before you even read it. And that's going to give you a leg up. And you're going to be answering them more correctly. You're going to be able to read, even if the wording is weird, you're going to be able to expect what they're going to be asking you. And so you're going to do better on them. So that's the goal here. Okay, so for homework, like I said, you're going to do that diagnostic test. And then the Test corrections are not due until Friday. So if you want to do them over the weekend, if you have some extra time over the weekend, just knock them out now. Otherwise, you can do them anytime during the week or on Friday. We don't even have school. You can do them on Friday and do them after you've turned in your assignments for other classes. Okay? So have a good weekend, guys, and I will see all of you on Monday.